The U.S. Navy has acknowledged that one of its operational destroyers recently demonstrated the combat use of a shipboard laser system, successfully countering multiple unmanned aerial targets during trials at sea. Lockheed Martin revealed that the Arleigh Burke class destroyer USS Preble used its high-energy laser with integrated optical Dazzler and surveillance on Helios system to detect, track, and defeat 4 drones as part of a Navy-led counter-UAS exercise. The test event occurred last year but became public only after being referenced in the company's most recent financial briefing, marking one of the clearest confirmations to date of Helios being employed against real aerial threats in an operational maritime setting. Lockheed Martin Chief Executive Jim Taiclet said, "Speaking of amazing technology, we successfully used the shipboard laser system, Lockheed Martin's Helios, to knock an incoming UAV right out of the sky. The Helios weapon system successfully neutralized 4 drone threats in a U.S. Navy-operated counter-UAS drone demonstration at sea, showcasing an opportunity to eliminate drone attacks using lasers and saving U.S. and allied air defense missiles for more advanced threats." In this video, Defense Updates analyzes why Helios is set to be a key defensive asset for U.S. Navy warships. Before we proceed, a word on NordVPN, which is one of the most trusted and fastest VPN brand that has a no-log policy validated by Deloitte. NordVPN provides a 256-bit encrypted tunnel that protects your privacy and also enables you to access contents that are blocked based on geolocation. Its threat protection system helps you avoid phishing, scams, and malware. NordVPN application is available for all the major platforms as well as browsers. Get an exclusive NordVPN deal with massive saving by going to nordvpn.com/defense or clicking the link in the description. It's risk-free with Nord's 30-day money-back guarantee. Helios, named after the Greek sun god, is a multi-mission system that combines high-energy laser power with optical Dazzler and surveillance capabilities. It is a solid-state, high-energy laser operating in the approximately 60-kilowatt class, with growth potential for higher power levels as shipboard electrical generation and thermal management improve. The laser uses a fiber laser architecture, combining multiple fiber modules to generate a coherent beam. This approach offers high electrical efficiency, scalability, and improved reliability compared to earlier chemical or bulk solid-state lasers. Lasers are concentrated beams of light that transmit large amounts of electromagnetic radiation against their targets. The general idea of laser beam weaponry is to hit a target with a train of brief pulses of light. The rapid evaporation and expansion of the surface cause shock waves that damage the target. When a laser beam strikes a target, it can cause the external surface to heat up rapidly. This can cause a drone, a rocket, or a shell to burst in the sky. Helios can also function as a dazzler, blinding or disrupting the optical seekers of incoming missiles and drones. Additionally, Helios is equipped with its own optical sensors, enabling a secondary role in intelligence, surveillance, and reconnaissance (ISR). Aboard the USS Preble, Helios is mounted on the warship's main forward pedestal, a position previously occupied by the Mark 15 Phalanx Close-In Weapon System, CIWS. The system is designed to draw power directly from the ship's electrical grid. Thermal management is handled through shipboard cooling systems, a key engineering challenge given the continuous wave nature of high-energy laser operation. Work on the system formally started in 2018 when Lockheed Martin was awarded a contract valued at roughly $150 million, structured to allow for future growth. The agreement encompassed the design and maturation of Helios, as well as the manufacture and delivery of 2 systems, one intended for shore-based evaluation and another configured for operational use at sea. USS Preble became the first surface combatant to be equipped with Helios, with the laser reportedly integrated directly into the Aegis combat system. Aegis represents the U.S. Navy's most advanced surface warfare architecture, engineered as a fully unified combat system in which sensors, fire control software, missile launchers, and operator interfaces function as a single, tightly coupled network rather than as independent components. The appeal of laser weapons lies in a combination of extreme precision and instantaneous engagement. Unlike conventional guns or missiles, a laser delivers its effect at the speed of light, eliminating time-of-flight delays and making it highly effective against fast maneuvering targets. As long as sufficient electrical power is available, the weapon can continue firing without concern for reloads, effectively providing a bottomless magazine. This characteristic alone fundamentally distinguishes directed energy weapons from ammunition-dependent systems and makes them particularly attractive for defending against massed, low-cost threats. Another major advantage is cost efficiency. Whereas interceptors and guided munitions can cost tens or even hundreds of thousands of dollars per shot, a laser engagement primarily consumes electricity. In practical terms, the marginal cost of a single firing can be negligible, often cited as being on the order of a few dollars or even less, dramatically improving the economics of sustained defense operations. Despite these advantages, laser weapon technology remains an evolving field. Engineers and scientists continue to refine beam control, power generation, thermal management, and integration with combat systems. Translating laboratory-level performance into reliable, repeatable results in operational environments is a complex process, especially on mobile platforms such as ships, where vibration, motion, and limited power margins must all be accounted for. Environmental factors present some of the most significant challenges. Because laser weapons rely on concentrated light energy, their effectiveness can be degraded by poor visibility conditions. Clouds, fog, dust, smoke, heavy rain, and maritime haze can absorb, refract, or scatter the beam, reducing the amount of energy that reaches the target. This not only lowers effective range, but can also increase the dwell time required to achieve a desired effect, limiting engagement capacity during adverse weather. In addition, laser systems are inherently constrained to line-of-sight engagements. Targets must be directly visible to the weapon, and obstacles or terrain can block or disrupt the beam path. Atmospheric turbulence further complicates matters by causing beam distortion, which engineers must mitigate through advanced tracking, adaptive optics, and fire control algorithms. The proliferation of cheap drones has changed the dynamics of the modern battlefield. Intercepting low-cost threats with high-end interceptor is not sustainable. This was clearly witnessed earlier, when in 2023, American forces in the Red Sea and Gulf of Aden were shooting down Houthi one-way attack drones and missiles fired from Yemen. The cost of those interceptions were too high. According to the Pentagon's Chief of Weapons Procurement, efforts to take out uncrewed aerial systems were exceeding $100,000 per shot. William LaPlante, the then Undersecretary of Defense for Acquisition and Sustainment at the Department of Defense, had noted at a conference hosted by the Center for Strategic and International Studies that efforts to stop drones fired by Houthi militants in Yemen are relying on costly missiles fired from Navy destroyers or fighter jets. He said it's getting too expensive. For reference, Standard Missile 2, a medium-range surface-to-air missile, can cost $2.1 million per shot, whereas CRAM is estimated to cost around $1 million per unit. Helios would be very useful in this kind of scenarios, and it is likely that more Arleigh Burke-class warships will have this system going forward.